Hi, this is Samuel here. So my task was to build or tweak a architecture of transformer which follows the attention mechanism. Basically, I chose T5 architecture, which consists of encoder and decoder. I also choose access to sentiment classification dataset, which is consists of 67,000 examples. I normally the encoder part uh, use the self attention part, and the decoder part use the cross attention part to generate the next token autoregressively. Like in this, it generate the next token in the autoregressive decoder part. As the dataset is a sentiment classification dataset, so I thought I don't need the decoder part, so I just remove the decoder part and use something here to just classify the part, the positive or negative part of the sentence. So now this is will be an encoder only architecture. So let's take an example. This is bad, okay, and we have to find its embedding, which will be something like 305 112 3 into 512, and then we have to add a positional embedding, which generally use sinusoidal curves equations to maintain the serial of the token sequence. And then we have to push our embeddings into a self-attention block. The self-attention block is something look like this, and it use the query and key mechanism to find out the relation between every tokens using something like this k transpose, uh, and you have to multiply with the value. Then when you get the attention context ever embeddings, then you have to use a residual connection here, and you have to add and normalize these embeddings. Then you have to further move it to the feed forward network, which has basically a learnable weights, and you have to learn these weights through the trainings. And further there will be further residual connections in the end, and then all the embeddings will be exact the same: 500 and 112, 3 into 500 and 112. You're just updating the embeddings with the more context. This is the most important part of the encoder. So now you receive the embedding from the encoder, which is basically 3 into 512 dimensions. The intention is to convert it in one dimension, so we have a small neural network to convert in this, like in this, to its learnable parameters, and the ultimate dimension will be something like this, like 3 is to 1. For this this is bad embedding, so each will have just one dimension, and then we have put a sigmoid on the dimension to fit in range of 0 to 1. And further, for the classification, we use a classification head, which output will be ultimately just two logits. Basically it will give 0 or 1, which will be classification of the sentence. And this is the whole architecture procedure of my custom T5. And I just remove the decoder part, and instead of decoder on the generating the next token, I use a classification module to generate the prediction of the sentence, negative or positive. I also try the reinforcement learning. There is very less scope uh, to integrate the reinforcement learning here. I use it for the training purpose. So basically, the classifier from the sentiment gate ultimately gives you the two output, like 0 and 1. For this here, we use cross entropy loss, and here I utilize this module as for reinforcement learning. I utilize this module as a policy module. Like if I give input, it will if I give its input, it will, if the prediction is correct, it will be 1, or otherwise it will give -1. This is how the PG loss is calculated, and cross entropy loss is the basic logics based losses. Then I will combine the total loss and the learning will be updated using the total loss ultimately. Here I utilize the reinforcement approach here. Now let's come to the deployment part. I utilized my GTX 1660 GPU for training the custom T5 model, and this is the whole Apache Airflow pipeline that is used for the deployment. First, I um, package the model into a tar file and upload it to an S3 bucket. Then from S3 bucket, I use the SageMaker serverless endpoints. So using this SageMaker endpoint, then I further use a lambda function to get the endpoint and API gateway for the REST API inference. And this is what it's look like in the Apache Airflow for the automation part. I use the check data. Check data is just basically some pre-processing steps in this, and then it's check model. I use some non-conventional way because I could not perform the whole training part in my Docker, so that's why I have to build that logic that if the previous trained model is better than the current accuracy, then I will further go for the next DAG. Then evaluate the model, then package, and here is the automation yeah, cloud service part. I will package the model, then deploy it to SageMaker AI, then further it's going for uh, a lambda function to API gateway, then just simply a test endpoint uh, in my script. I use a small test endpoint to validate it is working or not, something like that. So in AWS it looks something like this. This is the S3 bucket where the model is been stored, and this is the SageMaker AI part, and here is the model, and it's serverless, which is basically pay per request. Then there is the lambda function I used, and from the lambda function I use an API gateway to get the public root API endpoint. So that's it, and this is the code of the DAX hub, and this is the each DAG part and evaluate model and the all things. Thank you.